In this lesson, we're going to be talking about mortgages and loans. So amortization is the method of repaying a loan where the borrower makes regular payments of a fixed amount, part of which repays the amount borrowed, and the remainder of which is interest. So this is paying off a loan that probably sounds familiar to you. Home mortgages and many other loans are repaid in installment plans like this. To determine the amortization payment, what you do is you solve the present value annuity formula for R. So we've already learned this present value annuity formula in a prior section. Now we would like to solve it for R. So in order to do that, what you would do is you would multiply by this denominator on both sides, bringing it up next to the P, and then you would end up dividing by this giant numerator up here. And when you do that, the formula looks like this. So again, like has happened to us in many of our prior sections, there really is no difference in this case between the present value of an annuity formula and the amortization or the mortgage payment formula, except for they're just solved for different variables. One solved for P, one solved for R, the big R. So on this, big R still means the periodic payment amount. Capital P is the principal or the present value of that or the original loan amount. So this one is also going to be important in this section. Little r is your interest rate, T is your time in years, and M is the number of times compounded each year. So again, similar to sinking funds, we use this formula when we don't have the big R, the periodic payment, but we're trying to find that big R. And when you're doing this, you have to make sure you put the entire denominator in brackets or parentheses in your calculator when you're calculating so that it divides by all of this. Okay, so let's put this into practice. A home buyer is purchasing a $170,000 house. They're going to put $20,000 down, and the remainder will be financed by a 30-year mortgage at a rate of 4.25% interest compounded monthly. So this is fairly typical. The question is, what will the monthly payment be? So I can tell right now I am looking for a big R. I'm looking for this periodic payment amount. Okay, so I know the formula that I'm going to use. I'm going to use this R equals formula. Now the first thing we have to do is figure out, which sometimes with loans like this, like home mortgage loans, it's not so simple to find this P, this principal or the original loan amount. At first glance, you might think that that is $170,000. However, they put some money down first, so they aren't loaning all of that $170,000. So what their principal actually is you have to deduct, if there is a down payment, you have to deduct that off. So they're only loaning $150 in this case. So that's going to be our P, our principal. Okay, and then our formula says to do R over M. So the rate, the little r is 0.0425. M is compounded monthly, so 12, and our T is 30 years, so that should be everything we need. So let's see, we're going to have 0.04, I did my parentheses too small, 0.0425 over 12, big fraction bar, and set up a bracket. Inside these bracket, we're going to do 1 minus parenthesis. Inside this smaller parenthesis set, we have 1 plus the fraction 0.0425 over 12. We close up that smaller parenthesis set, and it's all to the negative 12 times 30 power, and then we close up our large bracket in the denominator. Okay, so again, I want to see this whole setup here for partial credit, for full credit on the exam. And then at that point, you can do whatever steps you feel comfortable with in your calculator. So in this case, I'm going to do 150,000 times, and then set up a parenthesis and say 0.0425 divided by 12. Okay, so just as a reminder for myself, because I like to write down kind of some steps, some reminders. So that's what the top ends up being. The top ends up being 531.25. And now I'm going to keep a running total though. So I'm going to say divided by, start it with a parenthesis, 1 minus another parenthesis, inside the smaller set, 1 plus 0.0425 over 12, close up that inner parenthesis, to the, you can either put the negative 12 times 30 power, or I happen to know that that is negative 3, oops, go back, negative 360, and then come back down and close up that large bracket for the entire denominator. Now I'm going to hit enter, and I get that the payment, I'm going to round to the nearest cent, is $737.91. So that is their monthly mortgage payment. Now there may be other types of questions, and similarly to the prior sections, if they ask you for anything other than either that periodic payment or that principal amount, the big R or the P, if they ask you for anything else, then there's other steps to be done. So how much does the buyer actually pay for this house total? Okay, well, they are making $737.91 payments 12 times a year for 30 years. And don't forget, if you had a down payment, you have to also count that in. That is money that they did pay for the house. They just didn't pay it on the loan. So this much repays the loan, and then this was their down payment. So if we want to sort of see that in its parts, then they paid $737.91 times, and 12 times 30 is just 360. We already knew that, so I'm just going to simplify that, shorthand it a little bit. So they repaid on their loan $265,647.60 plus the $20,000 down. So I'm going to add $20,000 to this now to find the total amount they pay for this house is $285,647.60. So this house was bought for $170,000. That was the price. They end up spending over $285,000 on it, though. Now, this is a bit of an eye-opener if you've never looked into home mortgages, but this is just how things work. You end up paying a lot more because it's spread out over 30 years, but you pay it in manageable chunks, and this is in no way to deter you from going and buying a house. How much of this was interest? Well, okay, so because of how we did Part B, this is fairly easy to look at because the $20,000 has nothing to do with interest, so we don't need to think about that at all. Interest is the difference amount from what they repaid on the loan and what they loaned. So they paid on the loan $265,647.60. That was the repay loan. And they only loaned $150,000. So if we find the difference there, so if I take 265,647.6 minus 150,000, then in interest they paid $115,647.60. So it's a lot of interest, but again, it's spread out over 30 years so that it doesn't hurt so much. I'm going to stop this video here because we have several other parts for this one. So we'll pick back up to answer these other parts in the next video.